Hi everyone, my name is Dean and you're listening to the MLOps podcast. As you probably know, machine learning in general and data science are two fields that are evolving all the time, and it's really hard to keep up to date. Specifically, the area of bringing machine learning into production or into the real world seems like it's very confusing. There's a lot going on and it's hard to make sense of all that's happening around you. But on the other hand, there are a lot of smart people that are doing great work in bringing their own projects into production. And we've had a chance to speak with a lot of these people, but it definitely seems like the information is not widespread enough and a lot of people don't know of best practices and how other teams work. So that's why we decided to start this podcast, where we'll be speaking with people who are working in various types of machine learning teams and hearing about how they are bringing their projects into production. I hope you find this interesting, and let's get started. Hi, everyone. Welcome to the MLOps podcast. My name is Dean, your host, and today I have Kyle Gallatin with me. Kyle holds a master's degree in molecular and cellular biology. He trained as a data scientist at the NYC Data Science Academy, where he now serves as a mentor to students. And then since graduating, he's been a data scientist at Fleetwood, followed by Pfizer. And there he transitioned into machine learning engineering. And he's currently a software engineer at Etsy, where he is building their machine learning platform. So hi, Kyle, thanks for joining.
Thanks, happy to be here.
Awesome. So I think you have a very unique path into the world of data science. And I'd love for you to share a bit about sort of how you got into this.
Yeah, absolutely. I always like to use this phrase that I kind of tripped and fell into it. While I was getting my master's in biology and kind of planning on going deeper into that route, I ended up getting an internship at a small biotech company where my job was basically to teach myself R and Python to analyze our internal data. Through that, I kind of learned about the whole world of data science and all the that was possible there. I'd taken some coding classes in college, but they hadn't really resonated with me. But I really got interested in R and Python through that internship, which led me to pursue that full-time boot camp and then go into the data science space from there. So yeah, from biology all the way into data science like that.
Interesting. So I guess one of the points that you mentioned is you did have experience in coding before and you didn't really like it. And so I'm curious, was sort of having a real world problem to work on the difference, or was it something else?
I think it was definitely the difference. It definitely took me a while to get over that first learning curve hump of coding. I took a MATLAB class my freshman year, and then I took a Scala class actually my sophomore year. So a little bit of statistical programming, a little bit of more functional object oriented stuff. But I always found it just frustratingly difficult to try and solve the sorts of problems that were assigned in class. But then when I was working on something real for a company and kind of saw it driving value, it definitely kind of changed my perspective of what programming was, and definitely the amount of enjoyment, the amount of satisfaction and enjoyment that I got out of it too.
Interesting. And the other thing that sort of stands out is you did sort of the entire gamut of sort of data related jobs, and you sort of are now in the more engineering oriented side of the spectrum. So was there a change or a point where you said, okay, maybe this coding thing is more interesting than I thought originally, or how did you end up where you are right now?
Yeah, I've always been more interested in the coding part than, for instance, the math part of data science and machine learning. I think I knew pretty early on it wasn't going to be making leaps and bounds, writing papers in deep learning or anything like that. And that my specialty was always in the practical side of things, implementing things, coding them out, and actually having them run. Through my work at Pfizer, I started to see a lot of machine learning projects fail to have impact because of the lack of software engineering expertise in a team or organization, and the lack of engineering practices that were going into deploying these models to production and managing them and all those sorts of things. So that's kind of really where I fostered an interest and saw a big opportunity to kind of almost be a specialist. in this like new area of like ML ops and like ML infrastructure and platforms.
Fair enough. Yeah, I feel like my main takeaway is like if you're now in a course or making your way into the world of data science and you feel like you're not as interested in coding as you thought you would be, that I in a sense your story is kind of inspirational, right? Because you're basically saying that the technical part is not prerequisite to getting into, or like being excited about the technical part is not a prerequisite to entering this field. Like you will need to work with code, and there's mostly no way around that today. Or at least for I think for the more interesting use cases, there's no way around that. But you can sort of adopt that or learn to love that after you learn to love or be interested in the actual problems that you're solving, which I think it should be inspiring and sort of reassuring to a lot of people who are now getting into it.
Yeah, definitely. I think that like one thing that I hear a lot of people say who haven't coded or like took one coding course and like look at the data science space or the software spaces, they say like I could never do that.
Mhm.
And I'm like, listen, like I know it definitely feels that way, but like trust me, just like anyone, all it takes is, you know, like time and some interest. And you would definitely get to the point where you're able to do it well.
Awesome. So this is already a good start to the episode. So then the next thing is you're now sort of taking lead on building the machine learning platform at Etsy. Like, I guess the first question is why, right? Because a lot of companies, like from our experience, a lot of companies today want to do machine learning. And then the next sort of logical step is we need a platform to support machine learning. In many cases, that's actually not a good first step, right? You want to start by actually proving that this provides value before you systematize things and all of that. So yeah, why did you build the platform and how is it structured?
Yeah, so first, like I guess I just want to say, like, I mean, I am definitely not the architect of this platform or the sole engineer by a long shot. So the platform actually started back in I think 2017, far long before I joined Etsy, like as a means to meet the needs of data scientists within the company. They wanted like a more standardized, you know, software engineering MLOps practices way to deploy models and maintain them in production. So I think all the way since back then, I mean, like, and probably even long before then, there's been value seen in machine learning at Etsy. It powers search, ads, and recommendations. And they do have frameworks set up where we can measure the real monetary impact of those frameworks, which is great. So I think essentially the value that like Etsy has, the value of machine learning for Etsy kind of justifies the existence of a very comprehensive platform to suit all of the needs of data scientists and machine learning practitioners, applied scientists within the organization.
And then can you share about how, like, what are the components of the platform?
Yeah, sure. So we do have, I mean, there's many different components. So the machine learning platform itself is split into two sides, very simply the training side and the serving side. There's also an ML system side, which deals with a lot of other stuff. And I feel like those two terms are always I've heard them used both ways in a lot of different companies, systems versus platform. But the platform is split into training and serving. So the serving side of things is where I work, and that's to do with real-time model inference. So essentially we deal with once a data scientist has trained a model, serving it in production, monitoring it, having observability over it, and all of the scale and performance considerations that come with that. The training side deals more with day-to-day experimentation and setting up like pipelines for new models, existing models, et cetera, and maintaining those over time.
And just for like to complete the image, what's the definition of the ML system side? Just so maybe people can structure this in their head.
I always think of it like there are a lot of different squads over on that side now. I personally think of it kind of like everything upstream of training and serving. There's a lot of feature systems up there. There's some other things to do with experimentation. There's some computer vision, like specialty systems and stuff that are being built out. But I like to think of it everything upstream of training and serving that deals with. There's a lot of feature services out there. Yeah.
Okay, fair enough. So it's like less on the let's say getting something ready to production and more on the getting something ready for like even training, right? So it's like an earlier step.
Yeah, that'd be a good way to put it. It's by no means like a hard line between the two. There's definitely overlap in lots of places that we collaborate, depending on like what part of the system is being worked on. But yeah.
Okay, that makes sense. And then, so all of this obviously is supposed to sort of make the lives of data scientists within the organization easier, simpler, more effective at sort of getting their work into production. And you did mention that there's sort of a split, right? Even on the platform side, you have the training side, you have the deployment side. Obviously, those are sort of connected in the sense that they happen one after the other when things are successful. I'm curious, like, how does the interface, if I'm a data scientist at Etsy, how is the interface with each part of this platform?
Yeah, for sure. So our like the training side of things, to get like I guess a little bit more like explicit and technical, we mainly use like Vertex AI now, which is the Google Cloud provider for like artificial intelligence, their platform. So we use Vertex pipelines for essentially writing like model DAGs out, which is a managed service that provides you access to Kubeflow. And then we use the Vertex platform or Vertex AI to actually like train those models. Once the model is trained, so I guess taking a step back, data scientists can kind of go on Vertex and then train and experiment with whatever they want. They can write, they can open up notebooks with whatever environment that they want, experiment with code, try out models, etc. And then when they're ready to kind of productize that more, they can work it into a Kubeflow DAG that will be on a schedule and run daily or something like that, which is great and super helpful. Once it goes to handoff to the serving side, we have a like model, we have a model management service that we call Barista internally that the serving squad manages. And that is essentially both a UI and API that acts as a control plane over Kubernetes. Okay. So through the different model serving essentially images or platforms that we support, like we support TensorFlow serving, Selvin, and an in-house one that was built quite a while ago, written in Python. Data scientists can create deployments on Kubernetes and then essentially take their model artifacts and configure their deployment with that artifact to run for inference.
Okay, so, well, I guess I have a bunch of questions. I think that's, at first sort of it makes sense, right? And then the sort of the next set of questions is about what are the, I don't know if limitations is the right word, but how does that work look in practice? So just touching on the last point that you made, so I can use like TF serving or Selden or your internal system. What does, like, as a data scientist, what does that require of me? Do I need to support a specific format, or like, does everything that works for those systems work for you as well?
Yeah, so I think, yeah, it definitely depends on what the, which one you're trying to go with. So when we built out like kind of our new platform, that was built as like a TensorFlow first platform. So there was a lot of push internally to adopt TensorFlow as the primary serving framework. So we kind of built a lot of our assumptions in the fact that most folks would be using TensorFlow. And all that requires from the TensorFlow serving perspective, I mean, we do have internal helper libraries and stuff, but all we require at this time really is like a TensorFlow saved model artifact. You can essentially pass that in, or essentially pass the location of it in from a blob store or something, and it will be loaded up in a TensorFlow serving container, and you get a deployment on Kubernetes. The reason we adopted Selvin as well was because we also wanted to maintain some flexibility in the platform. We didn't want TensorFlow to be the only modeling framework.
Mm-hmm.
Many of our older models served on our legacy in-house framework are like GBM. There are some TensorFlow models on there as well, and I think probably a dozen other frameworks like VW for some language stuff, I think. But we wanted people basically not to be limited to just TensorFlow and to be able to write whatever. So Selvin is a little bit of a different workflow where data scientists like write their own Python serving code and manage their own images like in their own repo. So that's kind of like the flexible side of things in that trade-off there, where like you can go with TensorFlow and just provide an artifact. But if you need or want more flexibility, you can write whatever you want, but then obviously you're responsible for more aspects of the code base and the serving code.
Yeah, I like that. I think that's a really great mental model. I feel like many times it's either or, and then you sort of lose on the trade-off on one side. Like either you're very inflexible, or you limit the sort of, or you require a lot of upfront work in order to sort of deploy a model. And so this sort of gives you a choose your adventure sort of paradigm where you can't complain, right? Like you want simple, just use TensorFlow. You want custom, then you need to do a bit more work in order to support that. That makes a lot of sense to me. And I think that would be something that I expect the market to go towards that direction, having more platforms do this and enable sort of that selection and not either or. And then the other part is like you have you have sort of a notion of experiments both on the training side and the deployment side. And obviously I guess this is true for any machine learning model that gets to a product. But I'm curious, like, so just explaining on the data science side, you have the experimentation of like trying different model types, right, and seeing how they what performs well. And then on the production side, you want to actually test the effect that has on sort of the downstream or the business metrics that maybe it's harder to measure once you train. So how does that look within your system? And is that something that you support natively or not?
Yeah, so like the experimentation side of like ML training is all about obviously those offline metrics, right? Like picking like area under the curve or some data science metric. I'm not a data scientist anymore. I won't even talk about it. But we actually have an entire experimentation platform that's built up around the concept of those A/B test experimentations for online metrics, essentially confirming that a model not only performs well offline with those metrics, but actually generates more revenue or leads to more clicks or more interactions with products or something like that. So we have an entire team actually that works on a platform to manage that and measure those online metrics once it's being served in our machine learning platform. So I would say it is fairly mature in that regard, that we definitely do have like comprehensive systems in place for evaluating those kinds of things. But I don't spend that much side on the experimentation side of things. I mostly focus on making sure a model is performant enough to get to the phase of experimentation.
Well, I guess I'm going to dig deeper on sort of one point here, and then we'll move on to performance, which I think is also super interesting. But that would put Etsy probably in a very advanced stage compared to most companies that at least I get a chance to speak with, where everyone, like, we're all data people, so we know the value of an A/B test and being data driven in your decision making and sort of what to bring into production and things like that. But setting up that framework is something that I don't see that often. Like companies talk about them wanting to do that in the future. It's not yet implemented usually, and that's fair. Like we're still growing as a market, I think, and that's okay. But yeah, what tips could you give if I'm a CTO of a company that wants to do this? How can I get there faster or better?
I'm sure that's like a $1 million question. I'd probably be in a different role if I could answer that effectively. But I don't know. Let me try and think. I mean, like, I think the first thing is really just not forgetting that they exist. I mean, if you're thinking about the layout of your company, at least this was true a couple of years ago, or has been for companies that were only hiring data scientists but not hiring software engineers. It's that like modeling and machine learning shouldn't exist in a vacuum, and you should have a proper number of teams to support every single phase that an actual machine learning model would go to. So it could be the simple advice of have a team dedicated to building out an experimentation platform, have a team dedicated to building out a machine learning platform. You will need different teams to essentially serve your data scientists and modelers internally so that you can deliver value with machine learning. You want modeling folks to focus on modeling. And then once they're ready, you want them to kind of hand that off through some clean interface to a team who specializes in infrastructure and scale. And you want a team that specializes in experimentation or data, essentially, to write software that compares the performance of two things in production and generates good metrics that you can trust, so that you can kind of escalate from there. I think it would be almost the structure of your organization and the good folks that you hire to kind of build that out and define that workflow, because machine learning by itself is just not going to deliver value without all of those other considerations.
Yeah, I think that one thing I can share from our experience is that it seems to me like the first step is having the people building the models speak the language, understand at least the language of the business side. Like if you ask someone what's your metric for success, and their answer is accuracy, even or area under the curve, it doesn't really matter. But that sort of is an indication that they're thinking about this as a technical problem to solve and not a business problem to solve. Whereas even if you don't have a good way to A/B test, but you realize that what you're trying to optimize for is, reducing churn, increasing conversion, whatever it is, then you're already one step ahead. And then the next part is, again, this is, I feel like I'm speaking from 30,000 feet above the terrain, and it's very hard to implement this. But I think another thing that you can think about is before building a model, start by implementing some naive solution and deploy that and see what happens. And that usually sets the stage for not being in the mentality of throwing machine learning at it, right? Which is dangerous because there's machine learning is awesome, right? And I definitely understand more than most why people would want to work on that and solve problems with it. But I think that sort of having that mentality and thinking about this as a product and not just as a technology might be a good first step, which doesn't require special technical abilities. But yeah, sorry, go ahead. You want to say something?
No, I mean, that makes a ton of sense. I mean, to take a ton of steps back, evaluate whether or not you need machine learning in the first place. My philosophy is definitely don't do it unless you need it. There are so many use cases I've seen where folks either want machine learning because it's machine learning or want to do machine learning for the problem because it's what they know. But the problem could be solved with just data structures and algorithms, or just a well-designed general hierarchical framework. So yeah, definitely don't jump
or an if else.
Or an if else. Yeah, exactly. Anything like that would be sufficient for many cases. Yeah, it's definitely not always necessary to do machine learning, and if you are, you should be ready for the investment that comes with it.
So yeah, so I think that let's dive into performance, right? So I think that this is also a topic that is I'm doing a complete switch, but yeah. But so you decided you want to deploy a model, right? And let's say the business needs, which also, by the way, this also relates to performance, right? Because if you don't know the business need, then you don't care whether the model is performant or not. You just want as many neurons, layers, whatever it is, and having the coolest model. But obviously, if you make the best prediction, but it takes 3 hours and the user expected it to happen after 3 seconds, then no user will wait to see your cool model spit out whatever it is. One thing that I think always comes up is who is responsible for this? Is it the platform team? Is it the data scientist? Or is it some other engineering team which does optimization?
Yeah, so I would say it's a joint effort because we have to look at kind of every layer of things going on. As the platform team, we're responsible for the cluster, um, sort of the deployments themselves, some of the other infrastructure like our English controller, load balancers, those sorts of things. But then when it comes to the actual like model latency itself, since data scientists can write whatever code they want with TensorFlow transform or add whatever layers they want to a network, obviously there's a lot of things that could happen within just the model itself to introduce latency. So if we kind of get to the phase of performance testing, which happens before experimentation, we're like, oh, this latency is relatively high, and we're actually working on an in-house framework right now to identify that as early in the pipeline as possible, almost at the training and experimentation side, to say, like, this will be like a high latency model or essentially cost a lot to serve at low latency. We try and work with them to either optimize infrastructure settings or identify specific places in the model that could be improved. For instance, with TensorFlow Transform, we've had instances where a simple nested for loop instead of more vectorized code has led from like 200 millisecond P99 latency going down to like 15 millisecond P99 latency at like the same RPS. And it's those kinds of things you're just like, wow, like there are little things you can do in your code that really just have a huge impact on how a model runs in production.
Yeah, that's really cool. I think that the like one interesting point there is how do you do knowledge preservation on that? Because it seems like a lot of these things are like someone tried out something or looked at the bytecode behind TensorFlow and realized that the for loop would be better. So do you have like a wiki for hacks for improving speed, or how does that look?
Yeah, so we do have we put together some code labs, which is kind of fun. Since we're TensorFlow first, we use TensorBoard primarily to like look at specific like operations in like the TensorFlow graph and stuff. Unfortunately, support for TensorBoard is a little bit more limited on the inference side than it is on the training side, and there's like less features you get. But you can still look at a lot of different parts of like the TensorFlow graph and say like, oh wow, like this operation is super expensive or taking up like this percentage of the time. And it has helped us in many instances identify bottlenecks where data scientists have gone back, rewritten some code, and we've ended up with a much more performant model.
Interesting. So would you say that that's usually the bottleneck? Like what percentage of bottlenecks are a result of like the actual model versus like data transformations, things like that?
Yeah, I guess like since it's more of like a accumulation of bottlenecks rather than, we've had like one or two times where it's like one bottleneck and it's like, bam, solved, done. But more often than not, it's kind of multiple improvements over time. We're like, oh, this could be improved, this could be improved, this could be improved. And making small changes to the code that have improved it over time. There's definitely always things we can do in the infrastructure side as well. We can always increase the amount of resources it gets, which increase costs. We can play with things like the client side timeout to essentially be like, all right, like users will get results a little bit slower as a general rule here, but we're okay with that for this model because it will give us better results still. But I think there are like more things that we've done on the modeling side, or a greater variety of things that we have done on the modeling side to decrease the latency serving time.
Interesting. So I'll just share another point here, which just came to mind is many times if you're doing a costly, an action that is perceived as costly from the user perspective. So there are differences between if the user expects something to happen in 0 time and then you take 5 seconds or something like that, or if you say like, listen, we're doing magic for you, and then you have a loader for 5 seconds and then you can get a lot by, even if it takes less than that, just sometimes the product advice is actually load for longer than the action takes because it looks like you're doing meaningful work for the user. So that might be, and jokes aside, like there are case studies that prove that this improves like conversion and things like that. So there's many ways to think outside the box about improving performance. Some of them might be not to improve performance, but actually to just reflect to the user some of the sort of magic that's happening behind the scenes. But yeah, I'm curious, like, there's a trade-off here, right? And the obviously every model requires like different a different decision making process, and then it depends on the task, it depends on like the maturity of the organization. But I'm curious, like, how do you guys balance the performance versus the results, and if you have any tips on how to think about this, like how, like a framework to adapt this to my company, right, or to any other company.
Yeah, for sure. I guess like it's interesting because even though we're the platform team, I mean, like it's not like we own these models, right? When it comes down to it, like this is like that is a product decision, whether or
Mm-hmm.
not you're okay with having something get back in X time at X cost. But we have thought about it, like where we've had really, really like a new iteration of a model that's very costly to serve. And it comes down to simple cost. It's like, all right, it's going to cost us this much annually to serve. It's going to like net us this much profit, compared to the old model. Are we okay with that from a monetary perspective overall? Are we okay with that from an environmental perspective, even if it's like that ridiculous of a model? And how should we move forward from here in a way that makes the most sense for the product? So it's thought about it in like the simplest terms. It's like cost of implementation and maintenance versus the profit, and yeah, it's often like a somewhat clear cut whether or not it's worth it.
Interesting. So yeah, but you just mean like, are you looking for a certain threshold of upside, and that's just it?
I guess it would like again that would probably depend on the product itself.
Mm-hmm.
I don't think we have like a universal framework for
Mm-hmm.
like no go if it's only if it's like this much of a margin and like yes above a threshold.
Mm-hmm.
So no, I wouldn't say it's specific. I can only imagine the number of like variables that would factor into whether or not that's the right decision for a specific product or a specific business. But at the end of the day, I'm sure product always makes the right decision.
Fair enough. And then sort of on the technical side, you mentioned this, I think, in passing, but you're basically saying that you're trying to build in the mechanisms to identify these bottlenecks as soon as possible. So what like to me, I guess what comes to mind is like a profiler, right? Like basically this is kind of like what you do on the web, or I guess you do this for any language, but like I recently looked at this on a website, and you want to see like what are the bottlenecks in loading a website, right? Because if it loads horribly, then people will just drop off. They don't want to wait. And so first, I'm curious if you have a machine learning profiler, that would be very cool. I don't know if that's something that exists right now. But yeah, but how do you build this into the model building process? Like how did that actually work?
Yeah, so first of all, we actually like are working on a profiler, which is pretty cool. I don't want to give too much away in case there's like the lead of that gets to talk about it later. But the fundamental idea is that we just run like profiling and like small contained load tests as
Mm-hmm.
early as possible in the model experimentation process where a data scientist is training. So if you're like testing out a model for the first time, you can very easily export a TensorFlow artifact. Deploy that to our dev environment with TensorBoard attached, and automate the run of some profiling using some data that you just trained with to see
Nice.
whether or not it's expensive to serve, and also export those TensorBoard results to get more insight into specific operations. So this like approach has already like identified like some bottlenecks like early in the process and like a couple models, and it's been great because as opposed to kind of like data scientists investing tons of hours and then getting to like the end stage and us spending like a month or two then trying to like cut back on features or cut back on transformations, we get to do that from like the moment that they're trying out new things early on in that process. So that's been huge for us in terms of identifying problems early.
And does that happen as part of the CI for some stage, or like when do I do this as a data scientist?
Yeah, so you can do it whenever. I mean, basically, we have it as like a CLI, but yeah, we're also like trying to write in automation where like you can basically just run this as part of your training pipeline,
Mm.
or run this as part of. I mean, you can run it wherever you want, but but yeah, it's essentially like if you have a model and data, you can write this into your pipeline, or you can run it ad hoc, however you want that makes sense for the phase of experimentation that you're currently at. But yeah, the important thing is that just that it's done and done early.
That's awesome. Like basically what you're saying is, I mean, these are a set of tools that are used everywhere in software development, but then you go into machine learning and that doesn't exist anywhere. So like having a profiler is such a basic thing that is so helpful. And then having unit tests and defining those, like the criteria that you care about, and then testing early, that's also it's taken for granted in software development, and then in machine learning it's just like science fiction. So it's awesome to hear that you're adopting those paradigms as well.
No, that's like, I mean, one of my personal philosophies is definitely that machine learning just like is software development or some specialized discipline of software development.
Mm-hmm.
And it's funny because every 2 years, like someone comes up with like ML ops or something like that. It took us forever to get to.
Mm-hmm.
And then, but it's like this huge, like mind blowing realization for machine learning that it needs to be more like software development. And then we do the same thing again with profiling or governance or whatever it's going to be. And it just like keeps happening, like one thing after the other. So I think the faster that we just make machine learning or take as many learnings from software development as we can to the machine learning side, the faster we'll kind of get to that, whatever the more end state of machine learning is. And maybe it's, infinite, like software development will just keep improving, getting better, and all of that.
I think those are wise words. I'm biased, but yeah. But okay, so you sort of, let's say we're now at the state where you provided tools for data scientists to identify bottlenecks and maybe places where they can improve. That usually leads to a point where we have seen in a bunch of people, in a bunch of organizations that we've spoken with, where you have to trade off between data scientists being familiar with frameworks. So the typical example is like pandas, right? With like different transformations that you can do versus the fact that some of these functions are not performant. And then you have to choose, like, do I enable the data scientists to use all of the framework, the entire framework as they know it? Or do I tell them, like, these are the functions that you're allowed to use in order to get good performant results? So I'm curious how that works at Etsy, and if you've figured something out that others can learn from.
Yeah, we're definitely not like super prescriptive. I mean, like, because we offer so much support around TensorFlow, for instance, like folks tend to use TensorFlow transform and like all of the TensorFlow functions. But when it comes to like what happens within there, we're definitely not prescriptive at all. And I think Etsy does have a high caliber of ML practitioner where we've had folks make contributions to open source TensorFlow because they've noticed like bottlenecks in specific functions.
That's nice. And
they're definitely, like by far and large the experts over there where we're not. But yeah, I think like besides being prescriptive with the general framework, we're usually not like, oh no, you can't do that or this. Functionally speaking, they're allowed to do like whatever. Even in the case of Selvin, it will, at the end of the day, if they get to a point where it's like infeasible from a product perspective, I think that like folks are aware of that and would avoid trying to get to that state to begin with.
I think that sort of, again, relates to the point of, if you think about this as part of a product, then you realize the limitations yourself, and it's not like, why are they forcing me not to be able to use this function, which is awesome. So that makes total sense. And then I guess the last question about performance that I'll ask is like, generally, what tips can you give for people that are trying to improve their models and sort of build out the systems for model performance evaluation?
I think it's software development. It's just like test early, test often, like write those unit tests early, understand how your model is performing early, because the later in the process that you do it, the more difficult it's going to be to cut your model back down to a state where it's reasonable to serve in production. It's the earlier that you identify it, the better that you can think about it as a consideration while building the model, as opposed to a blocker once the model is built.
That makes a lot of sense as well. So sort of taking a step back, or up, I guess. What are your thoughts about like machine learning infrastructure? How has it changed like since you've been working in this field, and what are the trends that you're seeing?
I think that it's like become a field, which is one thing. I think like when I first got into like data science, like MLOps wasn't really a term, and then like MLOps became a term, but I still didn't really hear the words like machine learning infrastructure, machine learning platform together.
Mm-hmm.
And then kind of out of that, I slowly started to see more roles that weren't machine learning engineer, but like software engineer or common machine learning, or like machine learning software engineer, or machine learning platform engineer.
Mm-hmm.
And I think that it's essentially like all other things in machine learning rising to the level of software engineering, where, like as a platform team working on machine learning, we get a lot of tips from, for instance, like our web infrastructure team or our search infrastructure team, who are like absolute experts in managing complex infrastructure for pieces of our product that have been running forever, and have like tons of tips and like tons of good things to learn from. And then they also help us out identifying the machine learning specific troubles that we have. We'd like serving a bunch of models in production has different considerations from, like hosting web services or whatever. And so we can kind of like help and work with them to make decisions to improve on the platform from there. And so, yeah, as a whole, I just see it coming to par with all of the other platform and infrastructure tooling that's been in place. And I see a ton of companies trying to build out platform teams. And maybe it's not like a statistical observation just from my LinkedIn DMs and folks I've spoken with, but I see a lot of people being like, we suddenly having this realization that they need to build out a machine learning platform
Mm-hmm.
for their internal data scientists to drive effective value with machine learning.
I like that. The fact that sort of adopting the mindset that you can just go over to the engineering team that's working on something completely different. But there are a lot of learnings that have happened there and can support what you're doing is a great tip, because most companies that have a machine learning team had an engineering team before. Not all, but most of them. So if you have someone senior there, then you definitely have the experience within the organization to learn from. I'll ask one follow-up to that, which is, as you said, there are differences. I'm curious if you found things that are helpful to mention upfront so that those engineers have the right mindset when they advise about scale.
Yeah, I think that one thing is definitely just like it's I guess how you set up your models in production. For instance, like auto scaling in Kubernetes, to be kind of specific. But for many folks, it's like if you have like an image already on a node, it's really easy to spin up a container and react very quickly to load with whatever application you're running a set of pods or set of replicas for. If we're serving a really, really large model, it needs to be loaded into memory and sometimes like warmed up before it actually starts to make inferences. So we have some deployments that like have readiness probes that take like 20 minutes because we're loading a huge model into memory. And it's not the kind of thing where you can just be like, oh, I'm going to react to load like that. You need to kind of preempt it more, or be a little bit more conservative in your estimates of when you shouldn't scale. So there's things like that just don't really apply in many other spaces where you're like just loading this massive like object into memory like the moment before you start an application. But things like that where it's just like a little bit less like, oh, you can do this. It's like, oh, well, you can't exactly do that. We do actually have a few more limitations because it's the machine learning space on how and when we can scale, or like what we can do to improve an application.
Awesome. I think that's a really useful tip. So thanks for sharing that.
Yeah, of course.
I guess like just for people who are trying to get a mental image of the scales that we're talking about, Can you talk a bit about sort of the scale of data, the scales of models that you're working with, just so people understand like where you're at, and then if there are any other counterintuitive adaptations like the one you just mentioned, that would be awesome.
Yeah, for sure. I mean, the scale is just like, I mean, well into the terabytes of like data generated per day. I don't even work with the data platform, but just in terms of like the small percentage of like feature requests that I know we log is like 30 something terabytes a day. Over our kind of big period this year, and I'm sure that's only a fraction of the actual data log per day. Over our like largest period around, you know, like Black Friday and that this year, we got up to like 280,000 requests per second on the machine learning platform, which and most of those are batched, and so that's like millions and millions and millions of predictions per second that we're kind of making on this platform. Like hundreds of nodes in the cluster at any given time, with like many of them being a minimum of like 32 CPU nodes. So it's fairly large, you know, and that's just our team. Yeah.
And is there, like, I'm guessing with what we spoke about A/B testing earlier, you also have this probably where you deploy to a smaller subset of users maybe, and then deploy it to the broader system. I'm curious if like when you transition between those two modes, are there like recurring themes of things you need to change in order to support that larger scale, or is it relatively straightforward?
Yeah, so it's usually we can kind of figure out like a good settings for a model, even with that smaller fraction. Speaking from the machine learning platform side, I'm sure there are broader considerations as we go further upstream between like stuff that goes on in web and upstream clients and search and all of that, and like machine learning systems with features and everything. But usually once we have like for all the complexities that come with machine learning deployments, like we're running stateless applications on Kubernetes. Like it's pretty simple in that regard. There's not a lot of, once you have it kind of figured out there, there's not a ton you can do to make it better or improve it. So even at like a small percentage of traffic, it's relatively easy for us to translate those settings to a model serving larger traffic. It's usually just making sure that we are not setting a very low cap on how high it can scale, and have a good sense of whether it's going to scale, you know, like linearly to what degree when it reaches the full amount of traffic, kind of estimating that beforehand and making sure our cluster can handle it.
So this is like this is a good segue into something that like we've spoken about in points throughout this conversation, but it is very obvious that you're working intensively with Kubernetes, right? And
Yeah.
both like yeah. So I mean personally, I'm like I think I mentioned this in one other episode that we recorded, but the first time you work with Docker, it seems like magic. It's like incredible the amount of things you can do with such a small amount of code lines, right? And the fact that it's so flexible and generic is crazy. And then you get to Kubernetes and it's like the next layer of magic. It's really insane, the fact that you can do so much with so little. But obviously, like for I guess it's reasonably so that people are sometimes intimidated by these two systems, right? And so I'm curious first, like, what are your thoughts about how familiar data scientists should be with these tools? And if you were now like if one of our listeners is a data scientist who wants to learn these tools because they understand that it's important, how would you have them approach it in a way that wouldn't scare them away after a day?
Yeah, for sure. I think that Docker is a ubiquitous tool that should be in every developer's like toolkit at this point, kind of including like ML practitioners and data scientists. It's just like too useful in the day-to-day, for like anything you might be doing to be something that you should like kind of ignore. It's super important, and because it's useful to like the everyday developer, I think that's something that everyone should know and has value in learning. Kubernetes, on the other hand, is something that's particular to scale. Kubernetes is like machine learning. Like if you don't need it, then don't do it.
Mm-hmm.
And so it's the kind of thing where if you're not working in it every day, there's probably value in picking up those skills and understanding what's going on. But no, you don't necessarily like need to go and learn it.
Mm-hmm.
Like I wanted to learn it as a data scientist and machine learning engineer because I thought it was really cool. And I thought that was like where I was interested in going, was the scale of machine learning applications. But yeah, if you want to learn it, I think there's a lot of great resources now. I mean, you can, if you have Docker desktop, you can just go into that drop-down UI, click enable Kubernetes, and you have Kubernetes running locally. And you can get the same kind of practice with like kubectl commands and like everyday Kubernetes stuff locally that you can in a real cluster to a degree. But you can get the same kind of low-level knowledge and everyday debugging knowledge of Kubernetes like locally, which is great. So if someone wanted to learn it, I would say just, like install it locally with whatever framework that you want, and just play around, take some courses, find some blogs. I wrote an article like Kubernetes for data scientists, which just has like a super high level, like serving a machine learning model locally with Kubernetes example.
Nice.
There's a ton of different stuff you can do to get familiar with it without breaking your personal bank and cloud costs or something.
Nice. I have a blog about Docker for data science. So together we're covering everything.
We got it all. Yeah, that's all you need to know. Those two things.
Yeah. I mean, I feel like it's there's this term of like onboarding users to complex systems of gradual exposure. Like if you have a list of 10 features and the user like starts using your tool or whatever product, and then you just show them a list of all the features, then they'll be scared away because it's like too overwhelming. And so what you actually want to do is like, here's one feature, and now that you know that, here's another feature that improves your life here. And so I feel like first Docker and Kubernetes sort of share that relationship. Like Docker is the single instance you can think about it, and then Kubernetes is what happens if I have a bunch of these running around doing multiple things and needing to communicate. So definitely like start with Docker and see that you have a decent handle of that. And I think that it's not hard to get to the basic level of just using it, understanding what's going on, and then like diving into specific containers if and when that's necessary. You don't have to be able to rewrite I mean, I guess for machine learning, there's this thing where a lot of courses tell you to re-implement like famous models, like write your own SVM, write your own neural network and things like that. So you don't have to do that with Docker. Like it's okay if you just know how to use it without knowing how to build it yourself. And then Kubernetes would be like the next step. And I think that there really is a lot of content, like just Google Docker/Kubernetes for data science. You'll find great stuff and you can start there. I guess just to finish off, I'll ask the general question that I like to finish with, which is like, what are your recommendations for the audience? So it might be related to to any of the topics that we discussed, but also, just like books you like, Netflix shows, whatever.
Recommendations for the audience in general. All the questions don't have an immediate answer for. I'm so all over the place. I don't know. My recommendation is like, I always see a lot of people wanting to get into data science or get into machine learning platform engineering or like go here or there. I like always just recommend people do what you're interested in, because there's like an infinite amount of learning to be done in any of those spaces, and like the amount of time you put in, or like the amount of love that you have for it, is like sometimes indicative of like how, I don't know, I don't even like that answer. You don't have to love it and spend all your time software engineering. That's a total that's a total
I think that maybe the sort of true part here is that if you don't have to love it, but if you love it, it will be sort of a good North Star for you, because you could just follow your curiosities, like pulling strings. I think this is general. Like, I guess loving something and being curious about something is not exactly the same. I think being curious is more like having questions. And if you could get to the point where you have questions about what you're doing and then like follow those answers to the next set of questions that you ask, then you will be able to to develop in whatever field that you want. Like there are still limitations, and of course, like, yeah, everyone has different circumstances and time allocations and things like that. But I do think that that plays a role. That being said, like, there are people that just work for a living, and that's also okay.
Yeah.
Yeah. So.
And yeah, I don't want to perpetuate like any kind of stereotype that that's how people should be living or software engineering, because, it's like not necessarily a mentally healthy way to live for a lot of people at all.
Mm-hmm.
But yeah, being curious is a great way to put it. Like, it's a good way to foster interest and develop in the field.
Mm-hmm. Fair enough. Trying to think if I have any new recommendations. The problem is, like, this is a meta comment, is we recorded the last few episodes in the span of a few days, so I feel like I don't have any new recommendations to give. Maybe like when I've started watching a Netflix show. So I mean, this is kind of like related to current events, but Netflix went ahead and translated the Servant of the People, which is the show that the current president of Ukraine, where he plays the president, like a teacher that becomes the president, and it's satire. It's pretty funny. Like, I'm enjoying it, and it's now like they have like English subtitles, so it's now accessible to non Ukrainian language speakers. So I'm enjoying that. Completely unrelated to data science, but if you want like a funny show, I think it's good. And then it's also crazy that like an actor that played the president actually became the president. Even the US doesn't provide like Hollywood stories like that. So yeah, I find that fun, and I recommend it. Yeah, that's it. Anything else you want to add before we wrap up?
No, I will check if that's available in the US. Yeah, watch a fair bit of Netflix myself. So I'll give a Netflix anime recommendation. Kotaro Lives Alone is actually pretty good. I watch a lot of anime. Real skeptical of Netflix original anime, but Kotaro Lives Alone, recommend it.
Nice. I got a recommendation from Netflix, and then I didn't watch because I feel like I'm overloaded with anime. So I'll check it out. Like, I just finished the most recent season of Demon Slayer, which is not a Netflix original, but I enjoy that. And so yeah, I'll check it out. Sorry?
Yeah, Demon Slayer was fantastic. Oh yeah, sorry, we can finish up though.
Yeah, no, it's good. This is part of the fun. But yeah, so Kyle, I really appreciate you coming on, and this was super interesting, and I'm sure a lot of the people listening will agree with me. So thank you again, and hope to have you again at some point. We can talk about sort of learnings and how everything evolved.
Yeah, absolutely. Thanks so much for having me on. I really appreciate it.
So thank you to the audience, all the listeners, viewers. It was great to have you here again, and I'll see you next time. Bye-bye.
Bye.
Thank you for listening to the MLOps podcast. If you enjoyed this episode, please like the video or subscribe. If you have any feedback, leave a comment below. Thanks again for listening, and see you next time.